Shanambir माते नहीं आता देखो
In this question, we are told that there is a Professor X. He devised a game to demonstrate the power of multi-level crowdsourcing, wherein there is a balloon that has to be caught, and every person recruits exactly one other person. So initially, the professor will select some guy A. He will recruit somebody else, say B, who will recruit somebody else, say C, and finally this goes on. And after a lot of time, there will be some guy say X, and finally there will be Y who will actually find the balloon. And if say this guy Y receives a money, say P, the amount of money that is received by X is P by 2. And the amount of money that is received by the guy who hired X is P by 4. And this continues. So even A is going to receive some money, which will be very small. It will be P divided by 2 to the power n, where n is a very large number. We are told that a lot of people were used for this volunteers. The chain of volunteers was very large. What we are required to calculate is what is the total amount of money that was spent by the professor to conduct this experiment. We are told that the person who recruited the last person received 2,000 rupees. So this guy over here received 2,000 rupees. So the guy who actually found the balloon would have received 4,000 rupees. And the guy who recruited this X, that is the person who received 2,000, received 1,000 rupees, and so on. So the total amount of money that was spent by the professor is 4,000 plus 2,000 plus 1,000 plus ... And this is a very large number, so it will eventually come, it will become very small, it will come close to 0. This is probably an infinite geometric progression. We are essentially asked to approximate this value. So you should know the sum of an infinite geometric progression. If you have a geometric progression where the first term is A, the second term is AR, the third term is AR square, and so on, such that the value of R lies between 1 and minus 1, then this infinite geometric progression, the sum will be equal to A divided by 1 minus R. In this particular case, the first term is 4,000 and the common ratio is half. So the sum is equal to 4,000 divided by 1 minus 1 by 2, which is equal to 8,000. As the number of people is not infinite, it is just a very large number. The overall sum will be less than 8,000, but it will be very close to 8,000. So what we are required to calculate is the approximate value. So that will be 8,000.